Jai Hind everyone. I Prashant Tripathi, Assistant Professor at Ajay Kumar Garg Engineering College, going to discuss a lecture on Global System for Mobile Communication. This topic belongs to BTech final year course for wireless and mobile communication, which has a code of KEC 076. The final year student can learn from this lecture about the different wireless technology which is based on global system for mobile communications. So the global system mobile communication is a standard for wireless communication and it is widely used across the whole world. Basically, the GSM system was implemented in Europe. Prior to GSM, the European continents uses different standard for communication purpose. But the problem was not a single equipment can provide services across all the continents in the Europe. So, to provide a uniformity, a standard which can exist across all the Europe, the global system for mobile communication has been implemented. GSM is basically a second generation cellular system and it was the first cellular system which uses digital modulation scheme and network architecture and services. It was originally developed to serve the pan-European cellular services and provide a wide range of network services using integrated service digital network. The popularity of global system for mobile communication increases day by day, and basically the modern technologies are based on this GSM standard. GSM services follows the integrated service digital network guideline and are classified as tele services or data services. Now we will discuss what are tele services and what are data services. The tele services means it provides the mobile telephony and it is based on mobile originated or base originated traffic. In tele services, the GSM provide services to subscriber and it enables subscriber to call any other subscriber or receive call from any other subscriber. In data services, basically GSM provide a standard for computer to computer communication and it is basically based on packet switched traffic in which the data is transmitted using small packets. Now we will discuss the GSM features. What are the GSM features which differentiate this standard from the previously existing standard? So, in GSM feature, there are two important facts. One is SIM and other is on-air privacy. So, this is the unique feature which GSM has provided and it is popularly known as SIM, Subscriber Identity Module. A subscriber identity module is basically a memory device that stores information such as subscriber identification number, network, the country where the subscriber is entitled to utilize services, privacy key, and other user related specific information. So it is basically work as a identification of subscriber, and using this SIM, different services can be accessed from the network. Without SIM, all user equipments are identical and non-operational. Without SIM, we can use our system only for emergency services. The second and important feature is on-air privacy. This feature is very important, and GSM has capability to provide on-air privacy, and it is virtually impossible to eavesdrop on a GSM radio transmission, which is the very important and unique feature of GSM standard. In this on-air privacy, using a key, we can encode or encrypt the transmitted bit stream which is sent by transmitter, and using that encryption key we can decode the received information. So only subscriber which is sending the information and the subscriber for which information has been sent can can understand the sent information. No other one can easily decode or understand the transmitted information. This was the very important and very unique feature of GSM. Now we will talk about the GSM system architecture. So in this figure, GSM system architecture is shown in figure. The MS stand for mobile station, and this is also known as subscriber equipment. This is the device through which the subscriber access the GSM architecture or GSM services. This mobile station is connected with BTS, which is known as base transceiver station. Base transceiver station, the word transceiver is a combination of transmitter and receiver. So it has facility to transmit and receive both. In BTS, we have transmitter and receiving antenna through which both function can be performed very easily. This BTS connects the mobile station with the remaining architecture. The BTS is installed in the different cell, and these cells made a small geographical area. The shape of these cells are hexagonal. The next component in GSM system architecture is BSC, which is known as base station controller. The function of base station controller is to control the different BTS and provide a coordination in between different BTS and the mobile switching center. So, BSC coordinate with different BTS installed in different cell and provide several important functions like handoff to ensure the proper communication and uninterrupted communication. The next component in this architecture is TC, that is transcoder. The transcoder is connected with MSC, which is known as mobile switching center. In mobile switching center, the main components are HLR, VLR, EIR, and AUC. These are the different registers which contains very important informations like HLR, as the name suggests, home location register, contains the information about the subscriber which is entitled to subscribe to utilize the services offered by the base station to which the subscriber is connected. Similarly, other component which play a vital role in establishment of call and other services are operational and maintenance center, which is known as OMC. So, as I have told that mobile station is the user equipment through which the subscriber access the GSM architecture. This mobile station consists of a SIM, subscriber identity module, which stores all user specific data and information, and mobile equipment is also a part of cellular system. Without SIM, only emergency call is possible. Mobile station can be identified by the IMEI number, which stands for International Mobile Equipment Identity. Through this IMEI number, the subscriber can be easily tracked whether its mobile is existing at a particular time. So, this IMEI number provide a unique feature for tracking of mobile system. The SIM card contains many other vital information such as identifier and table. It contains serial number, a list of subscribed services, a personal identification number which is known as PIN, PUC code, PIN unblocking key, basically it is known as PIN unblocking key, authentication key, and IMSI number, which is International Mobile Subscriber Identity. So, SIM contains all the information which are very important in GSM architecture. Using these information, we can track any mobile connected in the GSM architecture. Basically, the PIN number is used to unlock the mobile station. When we put multiple times wrong PIN code, our SIM get blocked. To unblock the SIM, we need the PUC number so that our mobile can function properly. Apart from these information, mobile station stores dynamic information while logged onto the GSM system. In this, the cipher key, which is represented by KC, and location information also stored in the mobile station. Using these information, we can trace that a particular subscriber exists at particular location at a particular time. So these information are very important. Apart from these information, one more important term is cipher key, and this cipher key provides the security regarding the transmitted data or information. Using these cipher key, the subscriber encode its information and transmit the encoded information securely over the wireless channel. Again, in this figure, the base station subsystem is shown in figure, where this mobile station is connected with base transceiver station using these antennas, and this base transceiver station is connected with base station controller. In this base station subsystem, basically 4 type of interface are used. The interface between mobile station and antenna is represented by UM. Air interface or interface. The interface between base transceiver station and BSC is represented by A-BIS. Similarly, the base station controller and transcoder are connected with A-tier interface. The BTS perform several functions like ciphering, speech processing, modulation, and demodulation. Ciphering is an important function which is performed by BTS. It basically uses a cipher key, and using this key, it encodes the information which is required to transmit. Speech processing is another important function. In this speech processing, different kind of functions are performed, and using these functions, the speech is converted into a form which is suitable for transmission. Like all the practical speech signals is analog in nature, but in GSM we are utilizing digital modulation technique, so there is a requirement of conversion of speech signal from analog to digital. So sampling, quantization, encoding operations are performed, and using these information, the speech signal is converted into digital signal. After conversion of speech from analog to digital, we need to shift the frequency spectrum of original speech signal to a higher frequency carrier, so that we can transmit the information over a long distance, and this requires the modulation. So in modulation, we transfer the information to a higher spectrum for the successful transmission of signal over a long distance. So BTS performs this kind of functions and ensure the proper communication between mobile station and base station controller. The base station controller perform many functions like call establishment, mobility management, statistical raw data collection. This BSC, base station controller, plays an important role for establishing the call. Apart from call establishment, mobility management is very important in wireless communication system, because In wireless communication system, the subscriber is not static, but it is mobile. So when subscriber leave his or her location and move to a new location, there is a requirement of call transfer from one BTS to another BTS. And this call transfer must be in such a way that there should be no disconnection or there should be no interruption. So this mobility management is also handled by base station controller. Other statistical data like call duration, functions which are required, other control are also managed by base station controller. The next component is transcoder, and transcoders are helpful for compressing the digital speech signal because compression is required so that we can efficiently transmit the data without wasting our bandwidth and power. So transcoder are used for compression the digital speech signal. Now we will discuss about mobile switching center. So mobile switching center basically perform call control, initiation of paging and charging data collection. The mobile switching center is further divided into four parts: HLR, VLR, EIR and authentication, that is AUC. So HLR is known as home location register, which contains the permanent information of the subscriber. It contains the subscriber identity number, the services which subscriber has subscribed, and the location of subscriber. So this home location register contains the information of that subscriber which is located at their home location. Similarly, VLR stands for Visitor Location Register, and it is a database which contains the information of visitor subscriber. Visitor subscriber means the subscriber which is not in their home location, but they has been moved to some other location. So their information is stored in visitor location register. It contains the security information for authentication of the SIM card and for ciphering. Also, it contains the subscriber identification number of visitor. The subscriber services is also stored in this visitor location register, and it contains the information about subscriber currently being serviced. Next component is authentication, which is a special protected part of for home location register. It provides security information to the network so that we can verify the SIM card and cipher the information transmitted in the air interface. So its main function is to verify, it provide to secure information over the network. It protect user identity and data transmission. And the last component of MSC is EIR, which is responsible for IMEI checking. It basically check whether a mobile which is subscribing the services or demanding the services is appropriate or not. It makes three lists of mobile. First list, which is known as white list, it is a list of valid IMEI numbers. Second list is gray list, which is a list of malfunctioning device. And third is blacklist, which contains the IMEI number, which stands for stolen mobile. So when we block our mobile which has been stolen, we directly report our IMEI number to MSC that we have lost this mobile phone and the services of this subscriber equipment must be blocked. So after checking all these information, the mobile switching center block the services corresponding to that subscriber equipment. The next and important part is operational support subsystem, which is a functional block of operation and maintenance center. It controls all the operations which the GSM architecture perform. Basically, it monitors the network in real time, collect data on network performance, traffic, status of network elements such as switches, base station, and routers. Its main function is to monitor traffic, net status report of network entities, subscriber and security management, accounting and billing. Now we will discuss that what frequency are used in GSM architecture. So in GSM, the mobile works on 2G standard and operates at 900 MHz, 1800 MHz and 2700 MHz. When any mobile is moving from India to USA, we required dual band so that it can work properly. So mostly mobile have dual band which uses two frequency range so that we can access the communication services at any location. In GSM 900 band, we use the uplink and downlink frequency. The uplink frequency range is 890 to 915 MHz, whereas the downlink frequency is 935 to 960 MHz. Here, the bandwidth is 25 MHz. Similarly, in GSM 1800, we have uplink frequency of 17102 to 1785 MHz and downlink frequency has a range of 18052 to 1880 MHz and it has a bandwidth of 75 MHz. The uplink and downlink frequency has a different range to avoid the interference between them. In GSM 900, the entire frequency band is divided into a bandwidth of 200 kilohertz. So the number of channel will be 25 megahertz divided by 200 kilohertz, and the number of channels which is utilized in GSM 900 is 125 channels. Similarly, for GSM 1800, the number of channels is 375. The available forward and reverse frequency band are divided into 200 kilohertz wide channels, which are known as absolute radio frequency channel number ARFCNS. The ARFCN denotes a forward and reverse channel pair which is separated in frequency by 45 MHz and each channel is time shared between 8 subscribers using time division multiple access technique. The GSM frame structure is shown in this figure. The 8 subscribers utilizes the time division multiple access frame and share their information on the time division multiple access basis. This for a user, a particular time slot is shown in this figure. It contains the user data, different encoding bits. This is the guard band to avoid the interference between the different subscribers. These are the different enabled bit for the proper transmission of information. A frame consists of 8 time slot as shown in this figure, and in a multi-frame such type of 26 frame are accumulated and such 51 multi-frame for a super frame which has a duration of 6.12 seconds. So this is the frame structure which exists in global system for mobile communication standard. This is also the expansion of frame structure, that is, one hyperframe contains 2715648 TDMA frames and it has a duration of 3 hours 28 minutes and 53 seconds and 760 milliseconds. So this is the time duration of total hyperframe. Now we can calculate the GSM 900 bit rate. As we know that in forward link the bandwidth is 25 megahertz and similarly in reverse link also, which is the link between mobile to base station, has a bandwidth of 25 megahertz. So the total number of channels is bandwidth divided by per channel bandwidth, and we have earlier discussed that the per channel bandwidth is 200 kilohertz. So there are 125 total channel available. Now the ARFCN is 0 to 124, which contains 125 channel. Now since 8 time slot are assigned per channel and the channel data rate is 270.833 kbps, the signaling bit duration will be 1 by channel data rate and it's come 3.692 microsecond. So the effective channel transmission rate is 270.833 divided by 8, which is 33.854 kbps. In GSM, with overhead, the user data is sent at 24.7 kbps instead of 33.854 kbps. In GSM, there are two types of channel used. One is known as physical channel and another is known as logical channel. In physical channel, the actual radio frequency resources used for communication between a mobile device and a base station. And logical channels are determined by the data carried by physical channels. In logical channels are abstractions that operate on top of physical channel and are used for a specific communication purpose. The term abstraction refers to the conceptual representation of certain communication functions or type of information that exist at a higher level of the communication protocol. This is the classification of channels. The channel is divided into two parts, traffic channel and control channel. Further, traffic channel is divided into traffic channel and data channel. And this control channel is divided into three parts, broadcast, dedicated, and common control channel. So this is the complete classification of GSM channel. So first we will discuss about traffic channel. So traffic channel carry the traffic which is originated in GSM architecture. There are two type of traffic channel, TCH full speed and TCH half speed, and these are used in both the uplink and downlink. Full rate speed channel carry digitized speech and 13 kbps data rate. After the channel coding had been applied, the overall rate increased to 22.8 kbps. Apart from TCH FS, there are also channels known as TCH F 9.6, TCH 4.8, TCH 2.4 are also used, and they carry data at a rate of 9.6 kbps, 4.8 kbps and 2.4 kbps respectively. Similarly, in half rate speech channel, these channels are designed to carry digitized speech which is sampled at a half rate of the full rate channel. The advantage of this was to enable GSM call to be supported on the same slot, thereby increasing the cell's capacity. Different type of half rate data channels are used, which are represented by TCH H 4.8, in which the data rate is 4.8 kbps, and TCH 2.4, where the data rate is 2400 kbps. Now we will discuss about control channel. As I told you that control channel is divided into three parts: broadcast control channel, common control channel, and dedicated control channel. In broadcast control channel, which is represented by BCH, is seen by mobiles that are entering the network. They provide an initial point of entry. The broadcast channel operates on the forward link of a specific ARFCN within each cell. Unlike TCH, which are duplex, BCH uses only the forward link. Now, the broadcast channel is divided into three types: frequency correction channel. The frequency correction channel is a broadcast channel used by the base station. It acts as a beacon within the control channel, and the mobile will first search for this when trying to access a base station. The burst, which is provided by frequency correction channel, is the first logical channel in control sequence. It basically consists of a string of 48 zeros, and when transmitted on GMSK scheme, it manifests itself as a sine wave at a frequency of 67.7 kilohertz when in case of GSM. The next classification is synchronization channel. The synchronization channel is a downlink broadcast channel, and it is sent by base station. The synchronization information is provided by this channel, and mobile phone use this information for base station identification and synchronize themselves with the base station. Next is broadcast control channel. The broadcast control channel is a logical Next is common control channel. The common control channel support common procedure required to establish a dedicated link with the global system for mobile communication network. It contains paging channel, access grant channel, and random access channel. In paging channel, The paging channel is used to inform the mobile that it has an incoming call. The paging channel can also be organized to allow for a sleep mode, which save the battery life. To achieve this, the mobile can be give a specific group of paging channels to monitor, and it will wake just in time to receive them and check if the mobile is being paged. Access grant channel has an incoming call. Access grant channel is used to provide the access to mobile station of the GSM architecture. Random access channel is used to originate from is random access channel originate from the mobile. It is used when a mobile wants to make a call and want a access of GSM architecture. The next is dedicated control channel. It is divided into two parts. Stand-alone dedicated control channel is a two-way logical channel that consists of 4 time slots in every multi-frame. Each mobile on the network is assigned to one of these channels. Similarly, in slow associated control channel, the slow associated control channel is a signaling channel that provides a relatively slow signaling connection. The last is dedicated control channel, and this channel is used for supervisory data transmission between the mobile station and base station during the call. These are the references which I have used for preparing this PowerPoint. Thank you.